There can be two main situations when we calculate the confidence intervals for a population. The population variance can be known or unknown. Depending on which situation we are in, we would use a different calculation method. All right, let's say you want to become a financial analyst and you are interested in the salary you are going to get. You are aware that the population's standard deviation of financial analyst salaries is equal to $15,000. Furthermore, you know the salaries are normally distributed, and we have a sample of 30 salaries. The formula for the confidence interval with known variance is given below. The population mean will fall between the sample mean minus z of alpha divided by 2 times the standard error and the sample mean plus z of alpha divided by 2 times the standard error. The sample mean is the point estimator. You know all about the standard error already, so let's compute it using the formula. What we have left is the so-called reliability factor, z of alpha divided by 2. Z is the statistic that we've described earlier, the standardized variable that has a standard normal distribution, right? And what about alpha? This is the same alpha we had when we defined the confidence level. So, for a confidence level of 95%, alpha would be equal to 5%. Similarly, for a confidence level of 99%, alpha would be equal to 1%. It all fits into place now. Let's get back to our example. The sample mean is $100,200, and the standard deviation is known to be $15,000. Thus, the standard error is $2,739. Having calculated these values allows us to take the next step and choose our confidence level. Common confidence levels are 90%, 95%, and 99%, with respective alphas of 10%, 5%, and 1%. Another way to put the value of alpha is 0.1, 0.05, and 0.01, respectively. Keep in mind that a 95% confidence interval means you are sure that in 95% of the cases, the population parameter would fall into your specified interval. The z of alpha comes from the so-called standard normal distribution table. It is best to first see it and then comment on it. Let's say that we want to find the values for the 95% confidence interval. Alpha is 0.05. Therefore, we are looking for z of alpha divided by 2, or 0.025. In the table, this will match the value of 1 minus 0.025, or 0.9775. The corresponding z-score comes from the sum of the row and column table headers associated with this cell. In our case, the value is 1.96. So, we have found the z-score. Now we can easily substitute in the formula. The final confidence interval becomes 94,833 to 105,568. The interpretation is the following. We are 95% confident that the average financial analyst salary will be in the interval 94,833 and $105,568. Perfect. In our next video, we'll explore an interesting variation of this task, calculating a confidence interval when the population variance is unknown. Thanks for watching.